So midterm elections were approaching last year. And the goal of our midterm election results day was very simple. Like we wanted to give our users the best experience ever in terms of the reliable and most up-to-date election results. But we have some challenges. And I'm going to talk about what will be the challenges for us that will stop us to achieving that goal that we wanted for them. The number one challenge is we completely migrated to the cloud in 2017. So our infrastructure, our technology stack is completely different than the election of 2016. So we cannot reference election 2016 preparation with the midterm elections 2018 because everything has changed. Not only that, as I mentioned, like we are a very technology company within. So we put a step forward and we empower the development teams that they are not only responsible for developing their application, they are also responsible for deploying their application as well. So we completely changed the model. Like we don't have a centralized infra team. Every team, they take care of developing, deploying, as well as if something breaks in the production, guess what? They are responsible for handling their production issues as well. So it's a big change in terms of the technology culture. The second thing is, which is a good problem to have, to be honest, we have more subscribers than election of 2016. Almost twice the number than we handled the traffic in 2016. So that's a good problem to have, but it's, again, as a technology, it just gives me more sweat that, oh, we're going to have more traffic. So if you consider these challenges, along with the political climate that we have, we were anticipating higher traffic on the midterm elections than normal. To handle those challenges and to make sure that we achieve our goal, we created a project called Operation Election Readiness. The mission of our Operation Election Readiness project was very simple. Like we wanted to organize a cross-team collaboration, and we are talking about more than 20 teams in terms of let's all work together and make sure that our site, our applications are stable, performant, and always up to date. So the project structure looks something like this, where we have election leads over here, where it's a small team who is responsible for making most of the decisions. And there are a bunch of program managers, product managers that help us organize this effort. And this is my team where we play the effort. So delivery engineering. So we were like the consultant to this election leads group, where you are giving them constant inputs on how to prepare for the election. And they used to help us organize that effort with the rest of the engineering teams. So let's talk about what were the activities that fall into our team. The first thing that fall into our thing is architecture reviews. So what it means is, if you remember me saying that now every team is responsible for their own deployment and infrastructure, guess what? They all are not expert. So we wanted to make sure that they follow the best practices. So we went into each team and look over how they are deploying. If they are stable, we access their resiliency and everything over there. Second, we did the stress testing. And this is what this today's talk about. What is stress testing and how we did that? Anyone in the room know what is stress testing? Wow. Phew. That's going to be fun. The third thing is incident management training. How hard we try, the bugs will always slip into production. Can anyone over here can guarantee that the system is bulletproof? That they will not have any bugs in the production? No one. That's what I expected. If anyone say, yes, I want to talk to you. So on election results night, we knew that something will go wrong, even though how hard we try. But our goal was, if something goes wrong, we want to be ready. We wanted to be ready to resolve the issues in less time possible. We wanted to reduce our MTTR, which is mean time to resolution. So for rest of the talk, we're going to talk about the stress testing. So stress testing, it's mostly used to check the upper limits of your system. In a very simple language, it's like you keep throwing the simulated traffic until your application breaks. And the goal is you want to find the bottlenecks in your infrastructure that will not allow you to scale. The second question will come to your mind is like, wait, what's the difference between stress testing and load testing? Is it not the same? It's almost same, but with a twist. In the load testing, you usually throw the traffic which is expected. For example, you are expecting 500 requests per second for your application. So you throw 500 requests per application, and then you analyze the system behavior in terms of how your system is behaving under the expected load. It's mostly used to determine the throughput. For example, checking the, when you want to set up your SLOs, SLIs, they usually do this kind of testing to get the numbers to start with. We also do a lot of load testing when we refactor our system to make sure we are improving our performance and not degrading it. On other hand, stress testing, there is no expected traffic. It's a fun thing. You keep going and going and going until it breaks. And when it breaks, you want to identify the bottlenecks. And usually stress testing is used for preparing high traffic events. And it could be anything. For us, it's an election results day. For someone, it could be selling a concert ticket, which usually gets sold out in first 5 minutes or maybe less than that. So that's a stress event for that website. So what were our key objectives of doing the stress testing for the midterm election results day? Our number one key objective was, now I can say, it's like we wanted to make sure our system is scalable. What I mean by scalable is how hard we try of configuring our application in the cloud, we will hit our bottleneck in terms of that will not allow us to scale. So we wanted to do the stress test to make sure what is our scalability, like what is our limit, and how we can improve that to make sure that we don't do that same thing in the election results day. Second, we just don't wanted to give user 200 HTTP code. We also wanted to make sure that our applications are performant. Like a user comes to NewYorkTimes.com website, and if it takes like 3 seconds to load the page, guess what? They're going to the other competitor and check the results. So loading your site slow is as bad as like giving 500 errors. Second, accurate. On election results day, everyone is looking for the election results as quickly as possible. And our newsroom works really hard to get the numbers as quick as possible. So we wanted to make sure the changes that they made appear on our site as quick as possible. And also we wanted to avoid the stale content. Like most of the application, we are also behind caching, like CDN systems. So we wanted to make sure that we don't serve the stale content. Again, on election results day, if your numbers are even off by 15 minutes, it's outdated. So it's a lot of competition of showing the results on the as quick as possible. Lastly, resilient. As we talk about, things will break. But when the things will break, we wanted to make sure our system is resilient. Like it knows how to recover by itself with the help of few folks. With that, I'm going to give to Prathamesh, who's going to talk more about stress testing, like how we plan for it and how did we run for it.
So let's talk about now how we plan for these stress tests. So when you plan for such a massive load test, the most important question is which tool you're going to use. So we decided to go with Apache JMeter. It's an open source JVM based application, and it's pretty awesome tool for writing a load test script. But how many of you have your machine, personal machine, capable enough to generate huge virtual traffic? No one? Okay, neither way. So what we did, we decided to partner with BlazeMeter for that. So BlazeMeter is a cloud-based virtual load generator tool. What they do, they accept the JMeter file as an input. They spin up a bunch of load generators in the cloud, execute the JMeter script, and give you result back. We could have done it with BlazeMeter, but it would have not been cost effective, as well as we would have ended up spending more time in bringing the server up and analyzing the test result. So this pair worked perfectly for us in terms of tooling. Let's talk about now which environment you use. So when we did this test, we wanted to do this test against a production mirror environment. How many of you here can confidently say that if you have a complex system with 20 plus applications, it's easy enough you can mirror it to test? No one, right? Yes. We would have done that. So, so looking at this slide, you must have figured out we did this test against our live production website. Isn't it cool to break our own production site? No? Yeah, I think ours. So our senior leadership team, they were brave enough to give us a sign off to do this test against production. Also our newsroom also, they were okay that, okay, you guys can go ahead and break the production site. So we got this an opportunity to break our production site, and we are thankful for both of them. Let's talk about now the internal coordination, which is important as we're gonna deal with 20 plus teams. It's not a one team effort, it's a collaborative effort. So we wanted to make sure we all are on the same track. Like if you deal with 20 development teams, you know everyone is having their own schedule and it's very hard to get everyone on the same page. So our project management team stepped in and they helped us in setting up the meetings and communications, and they help us in all this cross-team collaboration. So we're thankful for our project management team as well for helping us out in setting up the internal coordination. So timeline here is very important. So we wanted to make sure we are in sync with our newsroom, that when we plan to do this load test or stress test, we are not doing this when there is any major news event planned. So we were in sync with our newsroom as well, that when to do this stress test. External coordination. So nowadays many companies work with many external vendors. So if we would have done this test in secret, but what if for our external vendors, they must have thought, oh, sudden jump in a traffic, they must be under kind of some attack and they must have started blocking our traffic. So we wanted to make sure we are coordinating with all our external vendors as well, and we are giving them an opportunity to see how the election night will be. Failure plan. Yeah, all good. We plan for the best, but as we are testing in production, what if something goes wrong? So as Shesh mentioned, we came up with the incident management process. We came up with a bunch of scenarios that what if something goes down, what to do? What if something goes down, what to do? So we identified a bunch of scenarios. We also, in terms of communication, we contacted to our customer support team as well to let them know what to tell to our customers that if our site performance degraded during that time. And the last but not least, we didn't want to do this one exercise as a one-time thing. We wanted to see what's the impact it had. So what we did, we set up a process something called learning review. So what we did, we decided to create a timeline of the events so that later on, once this event is done, we can go over and analyze that what are the things went well for us, what are the things didn't go well for us, and some of the action items which we got out of that. So we did a blameless postmortem thing to get in some action items and to learn from our failures. So this is all about planning, like how we plan for this stress test. Let's talk about now how we prepare for this load test. So when you prepare for such a massive load test, the important question is you need to understand your application architecture. What I mean that, like when you talk with 20 plus teams, you need to know what is the business purpose of each application, what is the technology stack, what are the internal and external dependencies they have. So we spend some time in understanding all this information about the applications. Like what if they are using any kind of caching mechanism, what is that? So we collected that information and we applied during our stress test. So in next couple of slides, I have something called tip section. So this is some of the things we learned along the way or we implemented while doing our stress test. How many of you heard about content delivery networks? Handful of people, that's great. So nowadays many companies are using content delivery network like Fastly and Akamai to deliver the content to their customers. And their goal is to support huge traffic, but our goal is not to test content delivery network. So the point here I want to make is if your application is using any content delivery network, don't test your app through CDN. Go directly to your app. And the second point is if you are having any cache mechanism and if you hit your cache endpoints, you will not get the real time or how your application is performing. So hit your host directly to get real picture. Now let's talk about how we prepare a script for it. You all are familiar with JMeter by any chance? Yeah, so you all know JMeter is not a browser, right? It's an it's a tool, but it's not a browser. So when we are writing this test script, we wanted to make sure we are simulating an actual user behavior, like how the steps are when someone goes to invitetimes.com, what are the APIs we are calling. So when we go to invitetimes.com, internally we call many endpoints, like we call user info endpoint to get user information. So when we wrote the script, we wanted to make sure we are calling all these endpoints, not just invitetimes.com, all our internal dependencies. We identified the test data, like what kind of data we need for this test, like what are the cookies we requirement, what are the users we need. So we identified the test data, and the last is a publishing script. What I mean by publishing script is we wanted to mirror an election night. So when we are doing this stress test, we wanted to make sure someone is updating that article so that we can mimic exactly what the production night, election night will be. So we created a publishing script which was continuously updating articles at the time when we are doing or running this stress test. Some pointers here is, when you are sending an API request to a bunch of your internal dependencies, make sure you are making a full HTTP request call. Otherwise, your request will get blocked thinking you are under attack and kind of SYN attack. Now let's talk about the design, like how we design for this stress test. So we didn't want to throw traffic in one shot, like okay, just go for it and run the test against our production environment. No. We wanted to simulate an actual traffic, how it will be during election night. That okay, the traffic will be gradual for some time, then there will be a spike, then it will be gradual for some time. So we wanted to simulate all the possible scenarios. So for that, we understood, or we look over our all past patterns, and we got a graph that okay, we are designing the script, we wanted to make sure we are including all the pattern scenarios. The next important thing here is, we all know where is our app hosted, but if you are, the thing here is like, if you have your app hosted in GCP, don't generate a traffic from the GCP, because all the cloud providers, they do have some kind of internal networking, and then you will not get a real picture. So if you have your application hosted in AWS, make sure maybe to send traffic from GCP. And if you have app hosted in GCP, make sure to send traffic from AWS. And the location-based scenarios, what I mean by that, I think you saw the diagram which Shesh showed in the earlier, that we are not expecting traffic only from New York, we are expecting traffic from all geographic locations like East Coast, we are in East Coast, the West Coast and Midwest and all. So when we are doing this stress test, we wanted to make sure we are throwing traffic from all these different locations. Now, in terms of data, as I said, we created a bunch of test data, and we just didn't want to make our marketing team happy by seeing sudden spike in the subscription numbers and user information. So what we did, we provided a way for them to just scrap the data which we have created as a part of this test. So we use something called a referrer header. You can read here, we came up with such a unique referrer header so that it will be easy later on for teams just to scrap that old data, just not to give any false positive numbers to our upper management. What about ads? So when you make a call to the website, you see we make a call to ads, but we didn't want to give any false positives to our customers as well. So in this test, we didn't make any calls to our ads and analytics. Monitoring. This is important, like how, we are doing the stress test, but what we did, we set up a bunch of monitors so that system can monitor how they are doing when we are actually doing this stress test. We provided a way for teams to actually monitor how their application is doing in real time. What I mean by that, like our goal was not to serve only 200s, but we want our site to be performant because we are doing its stress test in a production. So we all were monitoring that how much response time is when we are running this test for 90% of the time and 95% of the time. So we identified some important metrics and we make sure to refer them during this stress test. So this is how we did for a design. So now let's talk about how we executed the day when we executed this test against our production side. So we were brave enough to decide to do this test during business hours, regular business hours, 9 to 5. And the goal of doing that is we wanted to make sure if something goes wrong, there will be immediate help available. So we had a room similar called war room, where we have representative of 20 plus people, the all engineering leads, and the person responsible for if something goes wrong, how to fix it. We had stakeholders in the room just to join us for the fun to see how New York Times website is doing when we see the huge traffic. And also we set up a communication protocol that how these teams will interact with each other when we will actually doing this test. Let's talk about now how we executed this test. As I said, when we reached to this point, all the applications had their script uploaded to BlazeMeter. They were all ready, 20 plus applications, they all come up with the script uploaded to the BlazeMeter. But having only one person responsible for running 20 plus scripts is not good. It's a lot of work for him. So what we did, we had multiple executors. One person was responsible for running tests for a couple of applications, like 4, 5. The second person was responsible for running tests for a couple of 2, 3 applications. So we had multiple executors in the room. Then we run this test in synchronous and incremental manner. What I mean by that is, as I said, when you go to nytimes.com, let's say for example, we make a call to any internal dependencies 2 times. So when you wanted to make sure, when you make a call to New York Times 2 times, the internal dependency is getting called 4 times, right? It's so that it will simulate the same load on both the applications. So we ran this test in synchronous manner. Also, we wanted to throw in traffic in incremental manner. Like we didn't just want to throw traffic in once. So we created a bunch of we created a timeline that, okay, at any given point, we wanted to make sure all applications are at having same load, what we are expecting as per our pattern. So for example, at maybe 10 minutes, A and B application will reach to a certain point. Then if commander says, okay, let's move on, put more load, all applications will start putting more load, and at the 20th point, maybe they all will be at level B. And the last part here is we did this test in 2 rounds. The goal of doing that is, you all know that we are not foolproof. Applications are not all foolproof. Yes. So when we did our first test, we wanted to make sure that we are learning from our findings, getting some action items, we are working on those action items and running this test again the second time, so that to make sure that we have worked on all our action items. Let's talk about results now. What do you think? Was it helpful? Did we break anything in our production? Yes, yes, yes. Here we go. That's the graph Shesh showed. This is the graph actually, it's from our production stress test. So we really broke our production website. So you can see here for first 45 minutes, everything was fine. The site was doing perfectly fine. But after that, it's not even performance degrade, it just started 500 errors. Like I'm done, kind of. So we are that's good that we did this test and we figured out the issues. What if we have seen the same during election day? Not good, right? So yeah, we think that whatever exercise we did was very helpful for us. Now I will pass it on to Shesh. He will talk about some of the key findings from this exercise. Thank you.
Yes, this was fun. As I showed you the first slide, you don't want to see this on the actual election results day. That's bad. Is everyone doing okay so far? There's a lot of stress tests. If not, I can talk about weather today for the whole next 10 minutes. So this is the weather forecast for rest of the week. I'm kidding. I don't have much information about it. I just copy pasted the screenshot. All right. So let's talk about, all right, we prepared for the stress test, we ran it, we broke it. But our goal was, we want to learn from it, right? What were our key findings? Our number one key finding was we identified a bunch of bottlenecks. If you remember like the graph over here, there was something interesting that we learned. In cloud, we always have a mentality that we will always grow and grow and grow, and they will help us all the way to the scalable. But it's also up to us on how we design the system and the cloud configuration. Over here, we exhausted something called cloud quota, which was very unknown to us. So every time you create an application in the cloud, AWS or GCP, they assign you certain kind of quotas. It could be HTTPS requests, connections, anything. And we exhausted our quota, and then we just didn't know what's happening because all our application metrics were showing everything is healthy. So we learned pretty good information about it. And then of course we talked to our cloud providers to increase our quota as well. So that was one of the examples. The another thing that we learned is we shoved the tech debt over the time under the table. Like every other company, let's do it next quarter, next year, and it just keep piling up. So we found out that a lot of the tech debt that we didn't handle it, now it's hurting us. This is the moment where it's like, oh, we need to fix them. Third is, we saw a lot of increased latency when we run the test for very first time. As we mentioned, we wanted to make sure site is performed as well. So yes, they were giving 200, but they were responding it very slowly when the traffic was going up. So a lot of teams learned so many things from the round one itself, and that they break, of course, and then they got a time to improve upon it. And when we run the test second time, they were able to resolve those errors and perform actually better. The second thing is we improved observability. So not only from technical perspective, for example, which system is depending on what, like what API is calling which API. When you work for a big company like New York Times, you often don't know who is your consumer of your API or who's actually calling your APIs. So that gives us a chance to know exactly who are your customers or who are your consumer of your API endpoints. Not only that, we found out what are the KPIs that we need to look for in the on the election results date that will show us the system health as quickly as possible. On top of this technical, we also found a lot of logistical use cases. For example, we know which team has to sit next to which team during that election results night. We identify that if we are having any representative from our cloud, which team they have to sit with. So there was a lot of logistical lessons that we learned as well. The third point is as I mentioned, we did break in the production, but guess what? It gives us a chance of exercising our incident management process. So it gives all the process that we put in the place a chance to do a real-time exercise. And we did that. And that was successful. Lastly, we now have more confidence. Even though we had challenges, even though we failed the first test, we passed the second test. And now we have more increased confidence that bring it on. We are ready. And not only handling the traffic, we also simulated something called the peak. So every time when you get notification on your phone from New York Times or CNN, for example, every time the users come to our site in a fraction of seconds. And that's a peak where we break the most of the stuff. So we simulated that exercise as well, that okay, you're already stressed. What if another peak comes in? So those kind of exercises give us more of confidence than ever. So let's talk about what really happened on the election results day. You guys will be all surprised. Trust me, even I was surprised. Any guesses on what is the traffic that we receive in terms of X, 5X, 10X? Any numbers in the room? No. We receive traffic up to 40x, and this is not normal for midterm elections, to be honest. So this also put us into surprise. Wow, this is more than we also anticipated. On top of that, we learned something. We learned something that we have never experienced before. Every time we keep saying that, oh, a high performance website equals to better user experience. But you always find how to find a connection between it and talk to your product managers. I'm sure you've all been to that boat where you want to say that, oh, you need to improve your quality, but okay, what will happen if you improve the quality? User experience, but you just can't because you don't have the numbers. This is the very first time where we were able to grow our user base in such a short time because we were able to give our user the best user experience ever that they have seen on the election results day. We give them the stable, performant, and up to date, and they give us the business. So that was pretty good. Third, we did break in the midterm elections night as well. Even though we tried, even though we did all the exercise, there was always an issue. And there was an issue with one of our GCS bucket going down. But guess what? because we were already prepared for it, we have already rehearsed our incident management test process, we were able to resolve that issue in a matter of single-digit minutes, which is a really quick response if you think about that, where it involves cloud provider as well. So there was a really small MTTR over here. On top of that, this was the very first time the New York Times has done any maturity exercise like this, where it brings whole New York Times engineering group together and do something, which was fun, but it also helped our higher leadership. Our higher leadership was so impressed that they told us we need to do this very often, not only for the elections, but let's keep a habit of doing like once a quarter to bring our resiliency and everything up for the production environment. More than ever, next year is our main elections 2020. And guess what? We are anticipating the high traffic even for the next year. But guess what? We are ready for it, because now we have planned for the whole year of doing maturity exercise like this every quarter. And we are also exploring other venues like war games, chaos engineering, because we learned that this is really helpful of doing these exercises. Yes, it's costly. Yes, you will not be able to develop any feature for a month. That will trouble a lot of product managers, but it's worth it. So I'll say all the efforts that we did, it involves like more than 40 people, to be honest, more than 20 teams, a lot of money spent, a lot of time engineering, handling this kind of stuff, but it was all worth it. With that, I would like to thank you for everyone for listening to us for 30 minutes. It's too much time in the morning, so I would like really thank you for that. We are hiring. If you are interested in working in the New York Times, please talk to us. As well as you can go to our site. We have roles for all the teams, to be honest. So whatever your forte is, we can hire it. I think that's all. Thank you so much.
Thank you. Thank you all.
Thank you.